Chapter 13, Kinetics of Particle, Force and Acceleration. So in chapter 1 or first lecture we started with classification of dynamics. Dynamics is classified into two parts, kinematics and kinetics. This is chapter 12. We learn kinematics of a particle or particle kinematics. Here we learn how motion happens and not why it happens. We are not worried about the forces involved, position, displacement, velocity, acceleration with respect to time. That's your chapter 12. But now in chapter 13 we learn particle kinetics. Here we are more concerned with why motion happens, forces involved with them. So altogether, forces involved with them and then how it causes this displacement, velocity and acceleration, we are going to try to understand that. So that's your particle kinetics. So here, this is the chapter 12 that we finished. Kinematics, particle kinematics, and now we'll start with kinetics of particle, force and acceleration. So in this chapter, we are going to state Newton's law as equation of motion. So Newton's second law is a foundation of dynamics. We are going to learn more about that, and then to analyze the accelerated motion of a particle using equation of motion. So we are going to learn Newton's law, and then we are going to apply that Newton's law or equation of motion, and then we are going to solve some problems with that. So that's pretty much we are going to do in this chapter. That's your particle kinetics, force and acceleration. So we know Newton's second law, when there is an unbalanced forces. First law says that all the forces all the forces in one object will balance each other out, and sum of that all the forces will be zero. That's your first law. That means that a particle or an object will stay at rest or continue to stay in motion with constant velocity, and all the forces acting on it zero. With Newton's second law, that's not the case. We have unbalanced force. So let's say force 1 here, force 2 here, and then there is an unbalanced resultant force in this direction. There is no other balanced force balancing these two forces, and if that happens, we can predict that this mass, this particle will accelerate in certain direction. So that's your Newton's second law, which says that all the forces equal to F equal to ma. If it is a first law, this one is zero. You don't have to worry about it. But as it is a second law, we have going to have some acceleration. So here, that's your free body diagram. If I want to draw kinetic diagram, something that represents motion, it will look something like this. Ma is this acceleration into this direction. Force is a vector, acceleration is a vector. So I'm going to have acceleration in this direction, and that's your kinetic diagram. And that's pretty much your Newton's second law. Here we know this Newton's second law is nothing but inertia force, this part, or I can say this acceleration is proportional to the mass, inversely proportional to the forces, inversely proportional to the mass. This mass acts as inertia force or total resistance to that acceleration, and that's your Newton's second law, which is a foundation of kinetics or dynamics overall. Now, in order to apply that Newton's second law as equation of motion, as it has a motion as acceleration, we call it equation of motion. And when we apply that Newton's second law, we have to use the concepts from classical mechanics, or also known as Newtonian mechanics or Newtonian frame of reference. If you are moving with speed of light or closer to speed of light, in that case you have to use Einstein's theory of relativity. But under normal conditions, under our everyday life, we are not moving with that much speed. So we use classical mechanics or Newtonian mechanics. What we do in this case, we fix the observer, and then with that observer fixed, we try to analyze the motion, we try to analyze the velocity and acceleration of any particle. So here, when we fix that coordinate system or we fix the observer, we call it as inertial frame of reference. It means that my observer is fixed, and now I'm going to analyze the motion of a particle. And then for that, we use rectangular coordinate or Cartesian coordinate system, or we use normal and tangential components, or we can use cylindrical, that's polar coordinate system, r and theta. We have to use some kind of coordinate system where we have observer or origin fixed, and from that, with respect to that origin, we are going to analyze motion, and that's what we call inertial frame of reference. So mostly when we apply equation of motion, as we are not moving closer to the speed of light, we apply equation of motion by considering this inertial frame of reference. So this is important part for us to understand. Then when we apply that equation of motion for system of particles, so if it's easier to calculate for one particle. If you have multiple system of particle like this, let's say you have cluster of stars or cluster of galaxies, and if you want to apply your equation of motion, that's Newton's second law for this particle. So what we do is that we have this imaginary boundary on that system, and then we take only external forces. So we apply the Newton's second law by considering sum of all forces, all external forces. So here F1, F2, F1, F2, F3, F4 or external forces. There will be some internal forces here. We are not going to consider that when we apply it for system of particles. So we only consider external forces is equal to summation of all the mass into all acceleration altogether. So here, to get that acceleration altogether, what we do is we take a point here, center of mass for the system, and then we try to understand the acceleration of that point. So here I'm going to rewrite my second law is as summation of all forces, external forces, is equal to mass into acceleration of the entire system, or acceleration of that gravitational point, and then I'm going to apply the equation of motion for system of particles. Now let's move on to the next part, inertial, first inertial frame of reference, that's rectangular coordinate. Let's say there is a particle which is moving along this path, and then there are some forces acted on it. So it has some acceleration, and as it has some acceleration, there will be some forces acting on it. So all those forces, or all the force, we are going to resolve into three components. So here we have, this is rectangular coordinates or Cartesian coordinate system, we have x, y, z axis. So I can resolve these forces into three components, fx, fy and fz. So combination of all three forces is guiding this particle along this path. So here if we apply this equation of motion to this particle, I will get summation of all forces equal to F equal to ma. So I can resolve these three forces like this, fxi, fyj plus fzk, and with respect to directions. So as it moves, as it has acceleration, that acceleration also I can resolve into three components. Those components will be ax, ay and az. Or I can rewrite those forces as all the forces in fx direction is max, that's acceleration in x direction, forces in y direction causing acceleration in y direction, and forces in z direction causing acceleration in z direction. So that's how I can rewrite these equations, or Newton's second law, for each direction. When we apply this xyz coordinate system, rectangular coordinates, we do that. We apply this equation and we try to calculate all the forces in x direction, y direction, and then acceleration in x and y, and then we will see how we do that. So that's how we apply this equation for rectangular coordinate system. Later we change the coordinate system. We will use normal, tangential component, cylindrical coordinate. This equation will be slightly different. But for now, for Cartesian coordinate system, these are the equations. If it is two-dimensional, most of the time we will have two-dimensional problem. We are not going to worry about three-dimensional problem. If that's the case, we are going to neglect that z, and in that case, I'm going to apply this equation, fx is equal to max, fy is equal to may. That's what we are going to use for two-dimension. Now, how to solve these problems? Normally what happens is that in this type of problem, you have some particle or some object moving, some forces are given, you may have to calculate acceleration, or acceleration is given, you may have to calculate one of the force. So that's the general idea. So how to solve these problems? So there is very specific step involved, and once you practice, you will get very familiar. Once you practice it, it will get easier. So what are these steps or procedure to solve this kind of problem? So very first, when you have this kind of problem, select a convenient inertial coordinate system. Either the problem is from rectangular coordinates, normal, tangential, or cylindrical. You have to choose that. So normally now we are going to start with rectangular coordinates. So let's say rectangular coordinate system. Once you have selected system, you have this rectangular coordinate system selected, draw a free body diagram. Free body diagram is something that you did in your static course. Free body diagram has only fx and fy, only forces are on it, and then nothing else there. So we have all the forces in x direction and y direction. That's your free body diagram. That's the second step. Third step, if needed, draw a kinetic diagram. That's optional. Kinetic diagram is something that now it has a motion too in this direction. Kinetic diagram represents the motion. So it has motion, x direction motion, y direction acceleration, and then here resultant acceleration. So that's called your kinetic diagram. Again, kinetic diagram is optional. Sometimes you need it, sometimes don't. You need free body diagram. If you want, sometimes you can draw kinetic diagram. Once you're done with kinetic diagram, apply equation of motion. So all the forces in x direction will be equal to max. All the forces in y direction is equal to may, acceleration in y direction. Apply this equation of motion. Write down all the forces, write down the acceleration y, write down, and then you will get two equations. So normally the way it works is, as I said, you have two equations, two unknowns, solve these two equations and then get the answer. So that's the general idea. So you have f1, f2, f3 is equal to mx. Here f1, f2, f3 is equal to mx. Sort that out and then find out what is acceleration of in x or y direction, something like that. So that's the general idea. And then there is another part. Once you know acceleration, it might be asked what is the velocity of a particle or how much distance is going to travel. So once you have this acceleration, you can use that acceleration into chapter 12 equations, these ones that you learn in chapter 12, very important equations. And then you can calculate how much distance traveled, what is the final velocity, all those travel, or how much time required. All that you can calculate once you have this acceleration. So that's the general idea. Once you solve this one, this will become chapter 12 problem, and then you follow chapter 12 process and you use this equation to solve the problem. So that's your step 6. So these are the steps that we follow when we solve these problems. Now let's go and jump on directly to the problem and let's try to solve this problem. So what we have in this problem, there is a toy car. There is this car here I have connected together and pulled with the force of 3.5 Newton. So in this problem, this toy car is pulled in this direction with the force of 3.5 Newton. The mass of the car is given here, 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 and what we want to find out, what is the acceleration of the car after car at 2-second mark. So here it says that we determine the acceleration of the car as well as car A and B. So you start pulling it, what will be the acceleration of the car, and then we want to find out what is the force between A and B. That's what the problem is. So here, for convenience, so all we want to do, initially it has 0, it starts from 3.5, it's going to move, this is a constant force is applied, it's going to move with some acceleration. We want to find out what is the acceleration, what is that constant acceleration with which it's going to move after applying this force. This is an unbalanced force. So step 1, in this type of problem, very first thing we define our coordinate system. Now for this particular problem, the force is in this direction. So what we are going to do is that define our x into this direction, y upward, and then x leftward positive. Only for this problem we can do that, but we don't have to do that. If you can do it other way, you will still get same answers only with negative sign. So here the force is applied into this direction, y direction upward, and now I want to calculate acceleration in this direction. So I have a force. Once I have selected coordinate system, which is rectangular coordinate system, I'm going to draw a free body diagram of this car. So let's say this is a block on which the force is applied. That's my free body diagram here. Weight applied downwards, normal reaction applied upwards. So these things cancel each other out. And then this only force here, x direction force, is going to make sure that this cart will move in that direction. There is no unbalanced force in this direction. So now my objective is to calculate the acceleration of this car. Once I draw a free body diagram, so this one is my free body diagram, I'm going to draw a kinetic diagram which represents motion. So this is the same block here, it's moving in this direction, total mass into acceleration. That's what we want to find out. That's the problem, find out the acceleration. So I'm going to apply this equation of motion here. Fx is equal to max, total mass of the car, all the forces in x direction and acceleration in x direction. Here I am going to assume that there is no y acceleration because these things cancel each other out. Cart is moving horizontally, so there is no y acceleration. So I am going to apply the equation only in x direction because I am going to need only ax. So all the forces in x direction, what are my forces? I have this force here, that's 3.5 Newton. I don't have anything else here, only 3.5 Newton here. So I'm going to apply that. So my force Fx is equal to 3.5 Newton. I'm going to put that 3.5 here. Mass of the train, total mass 0.15 plus 0.1 plus 0.1. I'm going to add that mass, that will be total mass here. And then we can calculate acceleration. So here 3.5 total mass into ax. Now all you have to do is that keep it here, take this one, that will come around 0.35, divide it by 3.5, and then 3.5 divided by 0.35 will be 10. So that's what the answer you will get. Ax is equal to 10 meter per second square in this direction. And that's what you get. So it's very simple problem. All you have to do is that apply your equation of motion in x direction. The force is given, calculate acceleration. So you do your calculations, and now you know this car will move in this direction with acceleration of 10 meter per second square. And that's it. That's pretty much your problem there. Now, once you're done with this problem, what it says that calculate the force between A and B. So here there is some force between A and B. I want to find out what is that force. So I'm going to apply, or I'm going to draw a free body diagram only for this part, block A. This is my block A, this is my free body diagram, and then all the forces on this, the weight downward, natural reaction upward, so it's going to normal reaction upward, so I'm going to cancel that out. Force 3.5, FAB I want to calculate. This is something I don't have. I know I have acceleration, I don't have FAB. So now just for this block A, I'm going to apply my equation of motion. Summation of all forces in x direction on block A is equal to ma, mass of my block, into acceleration 10. I know that. So here forces will be F positive minus 3.5 AB, that's my 3.5 minus FAB is equal to 0.15 into 10, and then that's how we can calculate. So here all the forces in x direction is F minus FAB. I'm going to put that, which is equal to max. I have to solve this equation. I know this one, I know this one, I know this one. I should get FAB, and that's what we do. We put the numbers in, and then you should get FAB as 2 Newton unit. Write down units always in your exam. So you have 2 Newton force here. So this one is moving with 3.5 Newton, but there is a force between 2 Newton between A and B, and that's how we can solve this problem, by applying equation of motion just for block A. That's very simple problem. Let's do a problem from the book. In this problem what we have is 50 kilogram crate. So this is a box or a crate is given as a 50 kilogram mass. Rest horizontal surface with coefficient of friction 0.3. So there is a surface with coefficient friction is given, and then it's being pulled by a force of 400 Newton at an angle 30 degrees. So there is some kind of crane in this angle, and it's pulling this against the friction here on the surface. So initially at rest, and you're going to apply this force, and then what it says is that determine the velocity at 3-second mark. So this is at rest. You're going to apply the force at 30 degree angle, start pull, 0 second, start 1 second, 2 second, 3 seconds. You're going to continue to pull, but at 3 seconds it will have some velocity. I want to know that velocity. That's the problem. So for that, if somehow we can find out acceleration, we can apply chapter 12 equation and we should be able to calculate velocity. So we have to find out what is the acceleration for this crate. So for the first part, we set up our coordinate system, normal x positive here, y upward positive. Set up our coordinate system, x, y. Once we set up our coordinate system, second step is draw a free body diagram. So we are going to draw a free body diagram. What are the forces on the crate? So on the crate, I have very first thing, weight, downward direction. Weight is mg, mass into gravity. Mass is 50 kilogram. 50 into gravity, 50 into 9.81. That will come 490.5 Newton downward. So that's your mg, Newton, downward direction. That's your weight. Second is normal reaction in upward direction. Third force is, of course, you are being pulled with 400 Newton at 30 degree angle. So here I can say this force in x direction will be 400 cos 30. In y direction it will be 400 sin 30. So you have 400 cos 30, 400 sin 30. This you can put these forces there, or you can simply keep it like that. It's up to you. So 400 sin 30, 400 cos 30. And then there is another force which is against motion because of the friction. As you start pulling, there will be some friction, and that friction force will be acting in opposite direction. So that my frictional force will be F equal to 0.3 Newton, acting in that direction. So these are the forces are there. That's my free body diagram with all the forces there. Once we're done with free body diagram, we are going to apply equation of motion. Equation of motion for x direction here all the forces in x direction, all the forces in y direction, max, may. So here we are going to assume that there is no y direction acceleration because there is none. This is going horizontally. We have this horizontal surface, so this one is going horizontally. This is not flying up in the air. So this ay is 0. There will be y forces, but they will not result in any acceleration. So ay is 0. There will be x acceleration. We have to find out acceleration. Once we can find out acceleration, we can calculate the velocity. So our objective is clear. Find out ax, find out velocity. So for that, I'm going to apply this, all the forces in x direction, all the forces in y direction. I'm going to write down this equation. So let's see what are forces in x direction. So very first force in x direction is 400 cos 30. So I'm going to put that one, 400 cos 30. And then I have this force here in opposite direction. So I'm going to put that down, minus 0.3 nc. So that's 1 minus 0.3 nc. I don't have anything else. So I'm going to write down as F is equal to max, 50 into 8. That's it. I have F is equal to ma. My object is to calculate it. Now, forces in y direction. This is normal reaction upward, 490 downward, and then I have another force here, 400 upward, 400 sine 30 upward. So I'm going to put that here. Normal reaction upward, weight downwards, and again positive 400 sine 30 is equal to 0. There is no y acceleration, and that's what two equations I get. Now in this equation, I have two unknowns, two equations. So I don't have acceleration, so I'm going to use this equation to calculate nc. Once I calculate nc, I'm going to take that value, I'm going to plug it here, and then I'm going to solve this equation to calculate acceleration, and that's the problem. It's very simple. So once we have acceleration, we are going to put that acceleration here, and then at 3-second mark, initial velocity 0, acceleration into 3-second mark, you will get velocity after 3 seconds, and that's how we can do it. Once you have acceleration, this becomes chapter 12 problem. You can calculate velocity by using this simple equation. Okay then. So let's put the numbers in. You can put the numbers in. If you want, you can pause the video, put the numbers in, and then you can calculate velocity. Here I'm going to directly continue. So if you put the numbers in, you will get the number for nc, you will get a number for acceleration, and then those numbers will be, normal reaction is 290.5 in upward direction, and then once you put that normal reaction here, you will get acceleration number is 5.18 meter per second square. So that's the acceleration. From this point you start pulling from 0, the acceleration will be 5.185 meter per second square. So that's initially from the rest it starts. That's the acceleration. It's a constant acceleration because the force is constant. So with constant acceleration, you are going to put that here and then multiply with 3. So 5.18 into 3, you will get velocity. So you do that, 5.18 into 3, and velocity is 15.5 meter per second. It means at 3-second mark, the velocity of this crate will be 15.5 meter per second, and that's how we can solve the problem. Let's move on to the next part, or in the same problem, calculate the distance traveled at 3-second mark. So everything is same. Acceleration, velocity, we have already. Now we want to find out how far it's gonna go. What is the distance traveled? So here, to calculate distance traveled, I'm going to use these two kinematic equations. Either one is fine. You can use this one or this one. This one, final distance is equal to initial distance 0, initial velocity 0, acceleration into time. You do that, you will get distance. Or you have velocity here, you put that here, and then you can calculate this as. So either way, you can use one of these equations and you can calculate total distance travel. In that case, if you are going to use this equation, one of these equations, the distance travel you will get is 23.33 meters. So 23.3 meters. Once it starts from 0, it's going to travel 23.3 meters. And that's the problem. It's very simple. Let's do another problem. This one is inclined mass problem. Now in this problem, what we have, is a mass here. This is a 6 kilogram mass. It's coming down, and then this one is 5 kilogram. Is pulling. There is a one rope, one pulley system. So here, as this is higher, it's going to come down, and then it's going to pull this one. So it's going to go move with same acceleration. So initially, let's assume that there is a support, and then you are going to remove the support. And as soon as you remove the support, this one is inclined at 30 degrees, and we are going to assume that there is no friction. It's very smooth. That's what we are going to assume here. What we want to do is find out the acceleration of the system. It means that at what acceleration this m1 is moving in this side and in this moving this side. Let's say there is no m1. In that case, we know that m2 will go down. It's a free fall with gravitational acceleration. We know that. But right now, there is a force which is pulling in this side. It's not a lot, but it's pulling in this direction, and that's causing a resistance for all the full acceleration. So we are going to get some acceleration here, but it will be less than 9.81. We want to find out how much. So here we are going to apply free body diagram. So there is nothing much to apply free body diagram. Here weight acting downward, the tension force is pulling upward. That's pretty much happening. This one, free body diagram is pulling this side. This one is 5 kilogram. So weight acting downward, that weight will be resolved into two components, as this is the force mg sine theta in this direction and mg cos theta in this direction. Here, this mg cos theta and then this normal reaction from the surface, again m1g cos theta, is going to cancel each other out. What does it mean? This reaction, this force in this direction, it will not cause any acceleration. There will be only one acceleration, as m1 will move in this direction as on smoothness, and then the resistance will be in this direction, or the resistance force will be in this direction. That will be mg sine theta, and that's the force we are going to consider here in this direction. So there are only two forces which are causing this acceleration or affecting the acceleration. This downward m2g, which is gravity, and this one, again this is a gravity at an angle, mg sine theta. And because of that, there will be some imbalance, and then we want to find out how this m1, how fast this m2 is going down. So now if we apply force equal to ma, acceleration here is equal to f net mt. So net force here, there are only two forces to consider, mg and this one, because these two, they are going to cancel each other out. So the net force is this force and this force. I'm going to write down that as m2 minus m1 sine theta into bracket g, or I can say m2g positive minus m1g sine theta, or I can take that g common, and that's what I do. I take that g common here, m2 minus m1 sine 30 g, and total mass m1 plus m2. So here this is our equation of motion. We apply that, and then we will get this one, and we are going to apply that. You put the numbers in, and then you will get final acceleration 3.12 meter per second square. So this mass is going to come down. This m1 is going to come in this direction with acceleration of 3.12. As I said, it's going to be lower than 9.81, and that's what we find out. It's lower than 9.81. So it's going to slowly come down with acceleration of 3.12 meter per second square. So once you get that right, apply this equation, and then you can find out. There is another problem from the book which involves this pulley and weight arrangement. What we have in this problem is a block A 100 kilogram and block B 20 kilogram. There is one rope and two pulleys. There is a support here initially. I'm going to take out the support, and as soon as I take out the support, this block A is going to come down because it's 100 kilogram. It's going to come down, and as it comes down, this block B is going to go up. I want to find out what is the velocity of block B at 2-second mark when it goes up. So initially t is equal to 0. Take it out, support, starts coming down 1 second, 2 second, 3 second. 0, 1 second, 2 second, 3 second. At 2-second mark, what is the velocity of block B, which is 20 kilogram? That's the problem. So if somehow we can find out the acceleration of B, we should be able to find out what is the velocity. So that's the problem, to find out acceleration. Now, to solve this problem, this is important. To solve this problem, first we draw a free body diagram of this one. Here, for this pulley, there is a tension force, tension force, tension force. So we have one rope, we will have one tension force. So I can say that there is a tension force here, there is a tension force here, and that tension force will be balanced with 2T, that's 2 tension force downward for this one here. Once I know there is a 2T tension here, I can go ahead for the next part to draw this diagram for A, and then it will look something like this. As this one is 2T, as is the tension force, I am going to put that tension force here, 2T upward direction, and this one 981 downward direction. Now important thing about this tension force is that tension force is a pull force. You cannot compress a rope. So rope always have a tension in it. And if you want to know the direction of a tension, how you can imagine is that you are standing in front of object and you are pulling the object towards you. That's the tension. So if I am standing in front of pulley here and I want to pull it, it will look like this. It will look like this. If I am standing here and here, it will look like this. For this weight, if I am standing above the weight, it will look like this in this direction. That's how the tension force works. You have to stand in front of object and then pull it. So for this one, I am going to stand here and then I am going to pull it. So the tension force here like this, and that's what the free body diagram we get. So tension force here, 196.2 weight, downward 20 into 9.81 downward. So that's mg. Downward direction weight, tension upward. This T is exactly same. That's the force throughout the system is exactly same. And that's what important part. So once you get the free body diagram right, this problem is very easy. If you don't get free body diagram right, that's the problem. So make sure that you understand this part. Tension here will become 2T. That 2T will become here 2T in upward direction. So 2T, 981 downward, 981 because mg, mass into gravity. So 100 into 9.81 is 981 Newton downward. You have this one, you have this one. Solve this, calculate the acceleration of AB. Once you have acceleration of AB, you can calculate the velocity. And that's the problem. So let's start with equations of motion. So once you have free body diagram for A, free body diagram for B, you can apply equation of motion here. Fy, now for this kind of problem, in chapter 12, remember we measured downward positive. That's what we do here. What we do is that we have a datum here. So everything downward, we take positive, phi plus. So make sure that you understand that. Everything downward positive. So all the forces are downward here. Positive is equal to Fy is equal to May. All the forces in y direction. There are two forces here. There is no x force. So we are going to consider only y direction forces. 2T upward, 981 downward. 981 positive minus 2T. That's going to be my number. So 981 minus 2T is equal to 100A. Ma, mass is 100 and acceleration A. I don't have an acceleration, so I'm going to keep it like that. Then for this one, 196.2 downward positive, T upward negative is equal to mass B, 20 into AB. 20 is mass, acceleration of B. My objective again to calculate this AB. Once I have AB, I can calculate the velocity after 2 seconds. So I have two equations, I have three unknowns. I don't know T, I don't know A, I don't know AB. I need something else in this problem. So for that we are going to use chapter 12. Chapter 12 relationship. In chapter 12, if you remember, we try to apply the equation for entire thing. So if we apply this equation, now here this block A, this block and this pulley is going to move with same velocity. So this distance I am going to see at as SA. This is a constant length SA. This one is again SA and this one is SB. This is constant length, constant length. So I am going to club that constant together from chapter 12. Then I will get an equation for the entire length. 2SA plus SB is equal to constant length. SA plus SA becomes 2SA plus SB becomes constant length. So that's what the process from chapter 12. Then I'm going to differentiate this equation with time. 2VA plus VB is equal to 0. So once I do that, I'll get this derivative of constant 0, 2VA plus VB, and that's the relationship between velocities. My objective is not to calculate directly velocity, but at this point I want to know what is acceleration. Once I have an acceleration, I can calculate velocity after 2-second mark. So I'm going to differentiate this equation one more time, and now I'll get 2AA plus AB is equal to 0. So that's the relationship between acceleration of A and B I'm looking for. It means that I can say 2AA is equal to minus AB. The minus sign because they have opposite direction. So 2AA is equal to minus AB. Now what I can do is that I can take this relationship, I can plug back in one of these equations. Once I do that, I have two equations, two unknowns. Then I can solve it for T, I can solve it for acceleration A, and then I can solve it for acceleration B. So now all you have to do, if you want, you can pause the video and then you can do this calculation and you can see, apply this relationship and calculate the value of A and AB. Now I'll go ahead and I will do this calculation for you if you don't want to pause. So here, once you have this relationship, once you get the acceleration of A and B, you are going to put into this equation, and that's your final velocity, acceleration of B into time 2 seconds, and then you should be able to calculate A, B velocity. So if you do this calculation, your velocity of A is get 3.27. As this one going downward, it is positive. So acceleration of A downward 3.27. Acceleration of B upward 6.54. This one is moving upward direction with 6.54 meter per second square acceleration. That's the acceleration you get. Now all you have to do is that take that 6.54, plug it here, and then into 2 seconds, and then you will get final velocity. And that's what we do, is that once we do it, it gets minus 13.1 meter per second, and that's it. So you have number. Now you know that once you take the support, this is going to come down, this is going to go up, and at 2 second mark, the velocity of block B will be 13.1 meter per second. That's it, that's the problem. Anyways, so again, for this kind of problem, you need lots and lots of practice, especially once you understand this part. Many students don't understand how this works, so many students fail to get this free body diagram right. They don't understand how much T2, T3, T4, T. And if you get this free body diagram wrong, then you will not get this one right, and then you will not reach here. So make sure that you know how the tension force work, how to get free body diagram. And once you have free body diagram, you can calculate accelerations, two equations, two unknowns, very simple process, and then you find your way through the final answer. In this case, it's 13.1 meter seconds. The minus sign is there because this one is moving upward direction. So that means upward. You can rewrite it as 13.1 and you can write down the direction upward. That is also fine. So minus 13.1, that's the answer here for velocity. Let's do another problem. Now in this problem, what's happening is that we have one pulley, one weight that is 3 kilogram is suspended. What's going to happen is that you are going to stand here and you're going to start pulling this rope. And the way you are going to pull is that the acceleration of this block is 5 meter per second square. So you want to find out at what force you have to pull this one down so that the acceleration will be exactly 5 meter per second square. Starts pulling down, it's going to go up. With this acceleration, how much force required for that? You have to find that out. So here again, this is a one rope, one tension. And then so I'm going to apply tension here, tension here. Tension is a pull force. Remember, I'm going to stand in the pulley on this rope and look at the pulley. I'm going to pull it. Tension, tension. That's tension, tension. It means there I will have 2T. That's the force here. And then this tension force will come here and here. It means that this tension force is nothing but our force required to pull. So that force here is nothing but T. This is the same T. We have to. It means that in this problem, we have to find out the tension force when the acceleration is 5 meter per second square. That's the problem when it is acceleration. So acceleration is given, find out the force. That's the problem. So I'm going to draw a free body diagram. If I draw a free body diagram, the diagram will look something like this. 2T upward, tension here, that will become 2T here, 2T upward direction, weight downward, weight mass into gravity, mass is 3 kg, gravity is 9.81, 3 into 9.81, whatever that will be downward. That's a free body diagram. Again for this problem, downward positive, so everything going downward is positive, upward negative. So here I am going to apply my equation of motion, downward positive, all the forces in y direction, mg downward positive minus 2T upward, tension force value of T we want to calculate, ma, mass 3, acceleration phi is given. That's what I am going to do. I am going to put that phi here, mass 3 into 9.81 minus 2T. One equation, one unknown. All you have to do is find the value of T. If you have time, you can pause the video, you can find out the value of T. That's it. That's the problem. One thing you have to keep in mind, the acceleration 5 meter is moving upward. This block is moving upward. It means that this 5 meter is minus 5 meter. It means this A is minus. So you have to put that there. So you have to put here acceleration is minus 5. And if you put minus 5, you will get answer as 22.2 Newton. It means that if you are going to pull this one with a force of 22.2 Newton, this one will move with 5 meter per second square. And that's it. That's pretty much it. Of course, we are going to assume that this pulley is weightless and then frictionless and all that. If that's the case, you will get this answer 22.2 Newton. So now, how does this pulley system work? We all know that using lots of pulleys make your life easier. You know that. But how does it work? So here, let's say what we have is the guys pulling this load. This is 100 Newton. So you have to put 100 Newton effort. So one rope, one pulley you are using. The same effort, only direction is different. It's going upward, downward, but effort is same. Like you are lifting something. 100 Newton here, 100 Newton here. But let's change the arrangement. Let's use different. What I'm going to do is that I'm going to use 2 pulleys and then I'm going to start pulling. So what happens is here, this weight, let's say this is 80 Newton, this gets divided here and here. Half here, 40 here, 40 here, and that 40 goes here, and now you are going to pull it with only 40 Newton. Here, all 100% you need require effort. In this case, you need only 50% effort. The trade-off here is distance. For this one, the same distance, if this is going to go upward 1 meter, you have to pull 1 meter down. This one, if you are going to move upward in 1 meter, you have to move 2 meters. And that's your trade-off. So your efforts are 50% less, but your distance traveled is 50%. It's twice more. So instead of 1 meter, you are going to travel 2 meters. So your mechanical advantage here is 2, but at the same time, you have to move the distance twice. Then let's assume that I have another system like this one. In this system, I have 4 pulleys. So what happens? My 100 Newton weight is divided into 4 parts here. 1 rope, 2, 3, 4. 25, 25, 25, 25. And that 25 will go like this here. It means for this 100 Newton, I have to pull only with 25 Newton force. I put it 25 and then I can lift whatever 100 Newton load. My trade-off is distance. This is going upward 1 meter. This is going to go 4 meters. So 4 times more distance. So my mechanical advantage here is 4. But now I'm going to raise, but the distance traveled is also 4 times higher. So it's going to take that much amount of distance. So that's how this pulley system works. Now there is very nice video in your PowerPoint slides. I already put it, I put the link. It's like 10 minutes video or something. Make sure that you watch that video. I'm not going to play it here in this part because I want you to, when you study, when you watch it. So make sure that you understand this video. It's very simple one. It's very funny video, but make sure that you go through that video. So that will tell you that simple mechanics for pulley with animation. So here I'm going to move to the next part. We have to find out how much weight you are going to go down this one is 100 Newton, at what force I should pull it so to get this 100 Newton upward. So here this 100 Newton, 50 here, 50 here, that 50 will go here, 25 here, 25 here, that 25 will come here. It means for this kind of arrangement, if I pull it with 25 Newton, I will get 100 Newton here. So here 50, 50, and again 25, 25, 25 here. The answer is 25. You get that 25 Newton and then you can pull 100 Newton up. For this one, 100 Newton, 50 here, 50 here, that 50 will go 25, 25 here, 25, 25 here. So I can write down that 50, 50 and then 25, 25, 25, 25. So this 25 will go here and then I put it with 25 force and then I can raise this up. So I'll get answer as 25. This one, I'm going to pull it down. This is 100 Newton, 1, 2, 3. This one doesn't count. So 1, 2, 3, 33, 33, 33. That 33 goes here. My answer should be 33 Newton. So here mechanical advantage of 3. 33.3 Newton, 1/3 of 100 Newton I put it and I can lift this one. So here mechanical advantage of 4, here mechanical advantage of 4, here mechanical advantage of 3. So you try to imagine this process, it gets easier with time. The another one, the same problem, here we have 100 Newton and then we want to find out how much force you are going to require. So for this one is easy, one pulley, one rope arrangement. You are going to need 100 Newton. This one 100 Newton, 100 here, 50 here, 50 here, and that 50 will go down here and that answer will be 50 Newton. For this one, I am going to have 1, 2, 3. So it's going to be divided by 3, 33, 33, 33, and then that 33 will go here, and then I'll have 33.3 Newton. For this one, 1, 2, 3, 4, 25, 25, 25, 25, that 25 will go here, and the answer will be 25. For this one, I have 6 rope, 1, 2, 3, 4, 5, 6. So it means divided by 6. It's like 16.6 Newton. So here 16, 16, 16, 16, 16. That 16.6 comes here and the answer will become 16.6 Newton. Here mechanical advantage of 6, advantage of 4, advantage of 3, advantage of 2, advantage of 1. That's how this system works. Again, watch that video. The link is there in the blackboard and you will understand more about this simple pulley system. This is very important, very interesting, very simple. Make sure that you learn it very well. Let's move on to the next part. Normal and tangential components. So far earlier we did the inertial coordinate system as your rectangular coordinate system was a Cartesian coordinate system. Now we are going to solve the problems with your inertial coordinate system in which we are going to use normal and tangential components. We use normal and tangential components before N and T, AT and AN. When you are taking a turn, you know the radius, you have this normal and tangential component acted on it on a curved path. If you know the radius, you can apply this normal and tangential component, and then in this case this normal and tangential component are fixed on a point itself. So here the forces acting in the normal direction, the way we have Fx and Fy, when you use normal and tangential we have Fn and Ft. Forces in tangential direction, forces in normal direction. So I have F here is equal to Ma, all the forces in this direction. So if I'm going to apply this normal and direction forces, I'm going to get this equation. Ft ut is our unit vector for tangential direction, un is unit vector for normal direction, Fn un is equal to mat man, acceleration in tangential, acceleration in normal direction. Or I can rewrite it like this: Ft is equal to mat, Fn is equal to man. And then these are, instead of Fx, Fy, we use Ft, Fn. And instead of Ax, Ay, we use At and An. And that's the difference between rectangular coordinate system and your normal and tangential components. Let's solve a problem directly here. This is very big and very interesting problem. Now in this problem, a 10 kg crate, this is a 10 kg crate or a box, it's traveling. So what's going to happen? This box starts somewhere here, let's say, and with gravity it's coming down. Then it's coming down at this instant. At this instant, this means total slope is like this. The slope, or equation for the slope is given 1/2 x 3 by 2. This is the equation for the slope. It starts here, it comes here. At this instant, the velocity is 20 meter per second. That's the instant. Here we get velocity as 20 meter per second. X equal to 16. That distance. And then it's going to continue to come down. What do we want to find out? Determine the normal force exerted by the slope on the crate. At this instant, it's coming down. At this instant, at any given instant, there is a normal force from the crate. But at this particular instant, if we freeze time at that velocity, I want to find out how much normal force in this direction acting on the crate. And that's the problem. And also it says, what is its acceleration? So at that instant, as it's coming down, what is the acceleration on that? I want to find out. So here, very first thing, we are going to apply our coordinate system, which is normal and tangential components. So this one is a slope, normal component here. Because we want to know normal force at that instant, we will have normal component in this direction on this object, tangential of course in the direction of the motion, so in this direction. So once you get your normal and tangential component, the next part is draw a free body diagram. This one is my free body diagram. Weight acting downward and then normal reaction into this direction, which is normal to the surface or perpendicular to the surface. These are the two forces acting on this one. That's my free body diagram. There is no other force here, normal and weight. Now, I can draw kinetic diagram which represents motion. So motion here, I can say that mt, that's a tangential acceleration in this direction, normal acceleration in this direction, and that's your at and an. And then it says later that find out what is acceleration. So if I somehow get the value of an, value of at, I should be able to get a acceleration at this point, and that's the idea in general. I want to find out at and an. Also here for these forces, I can resolve this normal direction force into this direction. I don't have to worry about that. This force, the weight acting downward, I have to resolve into two components, w sine theta and w cos theta. Theta is this angle that is making with this weight, this plane, normal plane making with this weight. This is theta and this is the force. Now if I want to solve this equation or solve this problem, the very first thing I need to know is theta. Without theta, I cannot apply the equation in normal and tangential direction, equation of motion. I cannot apply the second law for this problem unless I know theta. So my first part in this problem is to calculate theta and then apply equation of motion to solve the problem. That's the idea. Now, what we're going to do is that to calculate that theta, if I play around whole lot of the geometry, what I get is that this theta is nothing but this theta, it's making with horizontal. So this theta is exactly same with this theta here. It means somehow if I can find out theta here, I should be able to find out this theta, that is the same theta. So to find out that theta, what I'm going to do is that I know the equation of the slope. I know tan theta is nothing but dy by dx. That's my slope. Tan theta is equal to dy by dx. I have already y. I have to differentiate it with x here. So that's what I'm going to do. If I differentiate this thing with x, I'll get 3 by 8 x 1/2. So this 3 by 2 will go here, and then 3 by 2 minus 1 will be here. That will be 1/2. That will get 3 by 8 1/2. And once you have that, you have to find out value of theta at x is equal to 16. So I have here already x is equal to 16 meters. I'm going to take that 16 meters, put it in here, you will get some number. And then tan inverse of that number will be your value of theta. So that's what we are going to do here. 3 by 8, 16, 1/2, that's the tan inverse. This is the number. I'm going to solve this one is weight 1.5. So tan inverse of 1.5 is theta. So I'm going to write that down. Tan inverse of 1.5 is theta. And then the angle will get 56.3 degrees. So this angle, or particularly this angle, is 56.3 degrees. Now I have an angle, I know what are these forces. I already have weight 10 kilogram. So 10 kilogram, I have 10 cos 30, 10 into 9.81. So whatever 10 into 9.81 will be 98.1. 98.1 cos 56.3, 98.1 sine 56.3. Now I have these forces, I should be able to find out n. Now I am going to apply equation of motion. So once I have theta, my equation of motion for tangential direction and normal direction. My objective is to calculate n, then for acceleration to calculate an and at, put that an and at here, and then get an acceleration. So 3 things, 1, 2 and 3, I have to calculate 3 things here. I am going to apply the equation of motion, all the forces in tangential direction, normal direction. What are the forces in tangential direction? In tangential direction, there is only one force. This is my t, w sine theta. That's only one force. So I'm going to apply that here. I'll get w sine theta is equal to m at. That's it. Force in normal direction, I have two forces. One normal I have to calculate, that's positive, and opposite of that, w cos theta, that's negative. So I'm going to put that there. All the forces in n direction is normal, positive, minus w cos theta, because that has opposite of normal, which is this direction, is equal to man, mass into acceleration in normal direction. Now if you look at it, in this equation, I don't know n, that's what I want to calculate. I don't know an, and here it means that we can find out at, it's fairly easy. Still, it's kind of a 2 equation, 3 unknowns here. We don't know at and an, and even if we find out at, still we can find out because we need this an to calculate n. We have 2 equations, but we still need something more to get there. So now, to calculate this an, so you have to calculate n. You cannot do that unless you know an, normal acceleration. We are going to use this formula from chapter 12. V square by rho. Velocity we know, 20 meter per second. So at this instant the velocity is 20 meter per second. Velocity we already know. We have to find out rho. If you know the radius, we can get an. You can take that value of an here, you can solve the problem. So how to calculate radius? To calculate radius, we are going to use this equation. What we have here is the equation for the slope. And in case if you have equation for the slope, the radius at that point, at any given point here, will be given by this formula. Now it is a part of mathematics. Don't worry about how this formula is here. It's just plain simple. Mathematics is a plain short, it's a direct formula. You use it to calculate radius. All you have to do is solve this one, calculate the radius, use that radius here, calculate an, get that value of an here, calculate normal. That's the problem. So here it says 1 dy by dx square. So whatever the derivative of this one square, then double derivative here, absolute value. That's what we need here. So first single derivative, we already calculated that it is 1.5, and then double derivative. So I'm going to differentiate this equation one time. It will look something like this. This same thing differentiated again with x. If you do that, this 1.2 goes here and then it becomes minus 1.2. So 3 by 16x minus 1.2. That's your double derivative of this one, or single derivative of this one. Once you have that, put the value x is equal to 16 meter. Put that x is equal to 16 here, here, and then you will get the value of dy by dx and double derivative of that y equation. And then you can solve this one. So here what I'm going to do is that I put x is equal to 16. If I do that, I'll get this 1.5, and then this one I'll get 3.64. So now all I have to do is that put 1.5 here, 3 by 64 here, and solve this thing entirely. You will get density is equal to, radius is equal to, you will get some number. And normally that number is 124.999, but we are going to round it up, 125 meter. That's the radius you get. At this instant, the radius at x is equal to 16 is 125 meters. So now you take that 125, put it here, put it there, velocity is 20 square, that's 400. So 400 divided by 125, that's your an. Whatever the value of an, put it here, you'll get the normal. That's your first answer. Solve this equation, calculate 80. You have 80 and an, put it here, solve a, you are done with the number, we are done with this part. So an is 20 square by 125. So acceleration will come as 3.2 meter per second square. It means at this instant normal acceleration is 3.2 meter per square. So meter per second square, 3.2 here. You can calculate normal. So now if you want, you can pause it, put that 3.2 here, calculate normal, calculate 80 and get the acceleration. If you don't want, I'm going to continue with this problem. So I have normal acceleration, and then I'm going to solve this part. W sine, W is 98.1 into sine 56.3 is equal to mass 10 into 80. So a tangential acceleration will come 8.16. So it's coming down. This acceleration here tangentially is 8.16. Again, for this part we are going to assume that it is a smooth slope. Smooth slope means there is no friction. So keep that in mind, that there is no friction here because it is a smooth slope, and therefore we have tangential acceleration is 8.16 in this direction. So you have 80, you have an, you can solve this one. Normal will come around 86.4 Newton, that's your answer. Normal direction 86.4, and then use this 80, use this an, and then if you do that, 80 and an, you have these two values. You can calculate A as 8.77 meter per second square. So that's your final number for the acceleration. So now you know the normal, determine the normal, 86.4 Newton at this instant here from the surface, and the acceleration, total acceleration is 8.77. So that's your acceleration, and that's how you can solve this problem. These kind of problems takes a lot of practice, so make sure that you understand, you solve all the practice. I'm going to put some practice problems here. So the practice problems will be there. You don't have to submit anything. Practice problems are there at the end of the slides, or you can solve other problems from the book. More you practice, more you understand it, easier it gets. Do not read the problem. Take pen, take paper, take calculator, solve the problem. Otherwise you will make silly mistakes in exam. Don't do that. Make sure that you solve the problems, you understand. Even if you are going through this, take pen, paper, solve these problems, change the numbers, put your own number, create your own problem. Instead of 20, put it 30. Instead of 10, put it 35. Put different numbers and try to see how much forces change. Either they go upper or lower, how the acceleration changes. Try to think that way. Make your own problem, try to solve it on your own. Try to imagine the process, it gets easier. More practice you do, more time you spend, easier it gets. If you don't spend any time, if you just read it, if you don't understand the concept, you're not going to pass this course. So keep that in mind. I'm going to stop now. I have already put this on Blackboard. You will have these slides, you will have this video. And then once I get another time, I'm going to put the next video. Alright then, that's all for today. You stay safe.